Hello everyone. Okay, so in this video we are looking at plotting complex numbers and we're looking at the modulus. So what do I mean when I say I'm plotting complex numbers? So what I mean is when we plot real numbers, we use the number lines. You might remember this from primary school, 0, 1, 2, etc. Right? When I'm plotting numbers on the number line, I place them along this. So if I was plotting number 1, 1 goes here, 1.5 will go here, etc., etc. But what happens now when we introduce complex numbers and they have imaginary elements? Well, now we introduce a y-axis which will contain my imaginary component. So this is known as an Argand diagram. So an Argand diagram is used to represent numbers on the complex plane. This can be thought of as an extension of the number line for real numbers, with the imaginary part being represented through a vertical shift up and down, or i.e. on the y-axis. So the x-axis corresponds with the real part of the complex number, and the y-axis corresponds with the imaginary part of the complex number. So if we look here, I've just plotted the complex number 2 plus 3i. So we've got a 2 on my real axis, that's my real part. Go up to 3i, because that is my imaginary part. So 2 plus 3i, there it is. Plot it there. So that leads me into the modulus. So what is the modulus? So the modulus is denoted by 2 lines, like this. So it's 2 lines with the complex number inside it, like that. And the modulus of a complex number is the distance from the origin in the complex plane, i.e. it's the length of like this line, right? That is what the modulus is. It's the length from the center to that point. So we have a formula for the modulus, right, which is essentially an extension of your distance formula, but all you need to know is the modulus is the square root of a squared plus b squared, where z is equal to a plus b I. So let's have a look here at this one. So given that z is equal to 3 plus 4i, find the modulus of z. So that's equal to the square root of 3 squared plus, then b is going to be equal to 4. So 4 squared, that's going to be equal to square root of 9 plus 16, which is equal to the square root of 25, which is equal to 5. So therefore, the modulus of this of 3 plus 4i is equal to 5. So if I plot 3 plus 4i out, so here you go, on my real axis there's 3, go up to 4, there's my point. This distance here is going to be equal to 5. So let's do some practice problems. So this is from the Ordinary Level 2019 paper 1 question 2a. The complex number z1 equals 2 plus I, where I squared is equal to minus 1 and z2 is equal to 2 times z1. Investigate if the modulus of z2 is equal to the modulus of z1 plus the conjugate of z1. So that's a bit of a tricky one. So let's get started. So the modulus of z2. Well, z2, I'm led to believe, is to be 2 times zi, which is going to be 2 times all of this. So that's going to be 2 times 2, which is 4, and then 2 times I, which is 2i. So find the modulus of that, which is equal to the see that equal to the modulus of z1, which is 2 plus I, plus the conjugate of z1. So remember the conjugate, we just change the sign of the imaginary part. So it'll be 2 minus I. So the modulus of 4 plus 2i equals the modulus of 4. So let's see, let's investigate. So I have here square root of 4 squared plus 2 squared. And is that equal to the square root of 4? So I have here 16 plus 4 is equal to, I'll say that's 4 squared. Square root of 4 squared, which is going to be equal to 4. So root 20 equal to 4? No. So therefore, they are not equal. So they are not equal. How fun. Right. So let's move on to the next question. So this is from the 2018 paper. So it's another investigation. So given Z1 is equal to minus 2 plus 3i and Z2 is equal to minus 3 minus 2i, let's investigate, let Z3 equal Z1 minus Z2. Investigate if the modulus of Z3 equals the modulus of Z1 plus the modulus of Z2. So Z3 is equal to Z1 minus Z2. So that is equal to minus 2 plus 3i minus negative 3, negative 2i, which is going to be minus 2 plus 3i plus 3 plus 2i, which is equal to 1 plus 5i. So I have Z3 is equal to 1 plus 5i. So let's see if the moduluses are the same. So the modulus of 1 plus 5i equals, so that's equal to the modulus of Z1, which is minus 2 plus 3i, plus the modulus of minus 3 minus 2i. So this is going to be equal to the square root of 1 squared plus 5 squared, which is equal to the square root of minus 2 squared plus 3 squared, plus square root of minus 3 squared plus minus 2 squared, which is equal to root 26, which is equal to the square root of, so that's going to be 4 plus 9, which is 13. And then here is going to be equal to minus 3 squared is 9. 9 plus the square root of minus 2 all 3 squared is 4. So 9 plus 4, which is 13. So root 26, is that equal to 2 root 13? I don't think so. I don't think so. No, they are not equal. Therefore, investigate if they're equal. They are not. Right, so they are not equal. We have investigated where they're equal. Right, we have another investigation. I'm noticing a theme here. If this one, I swear to God, is not equal to each other, I'm going to scream. Right. Z1. So, Z1 is equal to 1 plus 3i. Z2 is equal to 2 minus i, where two complex numbers. Investigate if. Now, I imagine, let's just say that's equal to Z1. I think I made a typo. So Z2 minus Z1 is equal to the modulus of Z1 plus Z2. Let's try it out and see. So that's going to be 2 minus I minus 1 plus 3i, which is equal to 1 plus 3i plus 2 minus I. So 2 minus 1 is 1, minus I minus 3i minus 4i. So is the modulus of 1 minus 4i equal to the modulus of 1 plus 2 is 3. 3i minus I is plus 2i. So let's investigate. 1 squared plus minus 4 squared equals 3 squared plus 2 squared. So root 17, is that going to be equal to root 9 plus 4, which is 13. Is root 17 equal to root 13? No, they are not equal. Right, I'm noticing a little theme there. Right. So, let's look at the 2010 question. So, let u equal 4 plus 3i and w equals 6 minus 8i. Find the value of the real number k such that the modulus of u equals k times the modulus of w. So we want to find what k is equal to. So the modulus of u is going to be equal to, so a squared plus b squared square root. So it's going to be 4 squared plus 3 squared, which is going to be root 25, which is equal to 5. Modulus of w is equal to square root of 6 squared plus minus 8 squared, which is equal to 36 plus 64, which is root 100, which is equal to 10. So, modulus of u equals k times the modulus of w. So the modulus of u is equal to 5, is equal to k times 10. I want to get k on its own, divide both sides by 10. I'm going to get k is equal to a half. K is equal to a half. Right. Let's look at a final question here. Let z1 equal 3 minus 4i and z2 equal 1 plus 2i. Plot z1 and z2 on the Argand diagram, and then from your diagram, if possible, is it possible to say that z1, the modulus of z1 is greater than the modulus of z2? So let's have a look here. So I need to plot this 3 minus 4i. So go to minus 3, go down to minus 4. Oh god, I think I need to extend this a wee little bit. So minus 3 here, then minus 4. So 3 minus 4, there's z1. So the modulus is going to be from here to here. Right, then z2 is 1 plus 2i. So 1 plus 2i, which is like here. That's z2. So that line is going to, that modulus, the modulus is this distance here. So is it, if I were diagram, is it possible to say that the modulus of z1 is greater than the modulus of z2? I agree, so this line is bigger. So I would say yes as the line, or you could say yes as z1 is visibly bigger than z2, the modulus of z2, because it is. Verify your answer algebraically. So so now we need to find the actual modulus. So the modulus of z1 is going to be equal to the square root of, so it's going to be 3 squared plus minus 4 squared, which is square root of 9 plus 16, which is root 25, which is 5. So the modulus of z1 is equal to 5. And the modulus of z2 is going to be equal to the square root of 1 plus 2 squared. So a is equal to 1, b is equal to 2, which is equal to the square root of 1 plus 4, which is equal to the square root of 5. This is equal to the square root of 5. And then last time I checked, 5 is greater than root 5. Therefore, the modulus of z1 is greater than the modulus of z2. Bada boom, bada bing. Right. Next video we're going to be looking at transformations in modulus, and I hope this video was some help. And I'll catch you guys later. Bye.